We're going to take a closer look at our pressure control panel now. We have our pressure for our high pressure section that's coming from the compressed air from the building itself. It's going to come into our pressure control panel here through this needle valve. The needle valve is going to allow us to have fine tuning so that we don't over pressurize too quickly. This gauge here is going to be for our pressurized reading in the high pressure section. So if you look at this reading, it is in PSI. Also, if you'll notice at the moment, it has a 0 reading, which is indicating to us that this is gauge pressure as opposed to absolute pressure. So as we pressurize our high pressure section, this is going to increase to the point that the disc bursts. Our pressure regulator here is just set to protect our piping system itself. This selector switch allows us to either pressurize the high pressure section or to pull a vacuum on the low pressure section. We've got 2 shutoff valves here that regulate the ability to seal off both of the high pressure section and also allow us to remove pressure from each section after a test run. The final gauge that we have is the vacuum gauge. If you'll notice on this gauge, it is not in terms of PSI. This is a vacuum gauge in terms of inches of mercury. Again, we can look at that. That's a gauge reading. We've got a 0 value at the moment where we're at atmospheric pressure. So we're going to have increasing pressurized value. Again, vacuum pressure reads increasing values as the vacuum gets larger. If we'll notice here, we have this vacuum check button. This vacuum gauge is not always in operation because it cannot withstand the high pressure section. So we have to manually select to engage that reading again.
Okay, so we're just going to talk a little bit now about the pressure transducers that we have here. So as we've discussed, we have 2 pressure transducers at a known distance apart. This one here is going to be associated with channel 1 when we go to look at the oscilloscope settings, and this one will be channel 2. Now these are piezoelectric pressure transducers, which look something like that. They're affixed into the shock tube outer casing with a little cover on the top to stop us damaging that sensor. And basically these pressure transducers detect the change in pressure as the shock wave travels across it and reads a charge, which is converted into a voltage via the charge amp, which is then in turn fed into the oscilloscope to read our change in output voltage. So here we're just measuring the distance between the 2 pressure transducers, and as you can see, it's 30 inches between the first and second pressure transducers, and we're estimating our uncertainty based on the resolution of our tape measure here to be about 1/8 of an inch.
All right, we're going to take a little bit more look at the settings of the oscilloscope now. The oscilloscope is typically set to run continuously, but we're trying to capture, in this case, a shock wave, which is a very short event. So instead of allowing it to operate continuously, we want to look at operating it based off of a trigger setting where it captures a single event. So if we look at the oscilloscope and the output currently, it is operating continuously at the moment. Again, if we look at the signal output, we're going to see that there is a 0 output. Again, the piezoelectric pressure transducer is only going to measure a dynamic signal. So again, in this case, we're looking at operating it off of a trigger. So we're going to go to our trigger settings. If we look at our settings, we've got several different features. So the first is the type of signal that we're trying to capture. So in this case, we have an edge. That's exactly what we want to capture in this event, because we're going to expect, because of a shock wave passing, there to be a sharp, almost instantaneous pressure rise. So we're going to leave edge, and then specifically, we're going to look at the slope increasing. We're going to have a sharp pressure rise. We're going to trigger for our source being off of channel 1. That's our first pressure transducer. So once the shock wave passes that transducer and experiences a pressure rise, then it's going to trigger the oscilloscope to capture that event. If we look at the level corresponds to the pressure rise that we're looking for in order for the signal to capture. So we're going to go through and look at some generic settings, and then we're going to sanity check to make sure that it's working. So based off of our expectation of the pressure rise, we're going to initially set our divisions to 100 millivolt per division on both channels. Based off of our expected duration of the time of the shock, we're going to set our time division to 5 milliseconds. in order to sanity check to make sure that this is working properly, we're going to set our initial level to a 20 millivolt rise. If we look at this portion of the piping system, we have what is referred to as a strike plate. This is there just to put an instantaneous input signal, verify that the trigger settings are working, verify that the pressure transducers are working. So I'm going to set the oscilloscope to capture a single event, and then I'm going to hit the strike plate. If we now look at the oscilloscope, we can see that it did in fact capture a single event. I'm going to zoom in on time. And change voltage, and we can see that we captured the vibration of the input signal down the pipe. So again, this is not what we're expecting with the shock tube, but this is to verify that our settings are working. So now I'm going to go back, hit single to get it set up for another run for the shock wave itself. I'm also going to change the level because we're expecting a much larger change, and we're going to set that to 80 millivolts for our first run of the shock.
Okay, so as we just explained, we're going to separate the high and low pressure sections of the shock tube with one of these Mylar discs. So this is what it looks like a brand new one before we put it inside the tube, and once it bursts, you can see it has this kind of hat shape where it tears and sends the shock wave down the low pressure side. So what we do is we unscrew all of these bolts and bring the two sides of the tube apart a little bit so that we can fit a brand new one of these discs. There's a rubber flange inside the tube as well, which keeps it nice and airtight. So what we do is fit a brand new Mylar disc inside, rescrew all of the bolts, and then we're good to go for another run of the shock demo. Okay, so the final part of our setup here is this vacuum pump. Now, we're going to utilize this vacuum pump in the second run of our experiment. The first time we run this, we're going to have the low pressure side of the chamber at atmospheric pressure. When we repeat it, we're going to suck the air out using this vacuum pump. It's got a 1/3 of a horsepower motor in it. It will suck the air out of the low pressure side of the chamber so we can get it close to a vacuum. So now we're going to go ahead and replace the disc in the separating the two chambers to get ready for run number 1 of this shock tube demo.